Hello everyone. Welcome to my Kotlin crash course for Java developers. This is a tutorial meant for people who already have some programming knowledge, preferably in Java, and want to add Kotlin into your skill set. If you're just starting out and are looking for a beginner-friendly tutorial, I also have a Java for Beginners series on YouTube. I will put up a link right now in this video as well as down in the description. So go ahead and check it out. If you are still interested in Kotlin after learning Java, you can always come back to this video. The Kotlin language is in a fairly stable state right now, so no need to worry about the content of this video getting out of date anytime sooner. Anyways, let's jump right into IntelliJ and start learning about Kotlin. So right here inside of IntelliJ IDEA, let's create a new project. And let's choose Kotlin, and then we select JVM IDEA, and then we click Next. We call this project Kotlin CC, Kotlin Crash Course, and leave everything else on the default, and we can click on Finish. So it configures Kotlin for this project. And on the left-hand side, it's our project structure, and we click on our project, and the source folder is where we should create our Kotlin file and write our code. So we click on the source folder, and we choose New, and we choose Kotlin file/class. Let's give this a name called tutorial, and select File, and then we click OK. So right here we have a .kt file. This is the extension name for Kotlin programs. Let's write a hello world program using the Kotlin language. Through this example, we're going to see how Kotlin is different from Java in terms of the basic syntax. So here's how the program looks like. We're going to start with a definition for the function main. So we say keyword fun, and then followed by the function name, which is main, and then the parameter list, and the curly braces. Inside of curly braces should be our function body. We want to print out hello world, so we use the function println. And then inside of the curly braces, we say hello world. And that's it. That's our hello world program in Kotlin. And now let's run this, see if we can get the hello world printed out on the console. And there we go. We got hello world. And let's take a look at this program. The first thing we notice is that the Kotlin language doesn't require us to put all of our code inside of a class. So not like Java, in Kotlin, functions can be used at the package level. So this really reduces the code complexity in our program structure. And another thing that I want to mention is for our main method, we can, if we don't need any arguments, we cannot, we can omit the command line arguments and just leave the parentheses empty. And the next difference is, maybe you noticed, is that semicolons are optional. So we can put semicolons after our statement, and it won't have any impact on our program results. If we run this, we still get hello world. But for simplicity, we can omit semicolon, and the program still works the same. Next, let's talk about variables. There are two ways to define variables in Kotlin. The first one is to use the keyword val. So let me show you how to do that. So we say val, and then it's the variable name, and then followed by the initial value of this variable. That's how we use val. And another way is to use the keyword var, which is very similar. There's only the keyword is different. We can say the variable name is language equals and Java. And the differences between val and var is that a val variable, in this case, its name equals Kotlin. This name variable is immutable, which means we cannot change the value once it is initialized. But a var variable is mutable, which means we can change the value once it is initialized. So if we do language equals C++, that's fine, right? The compiler doesn't complain. But if we do name equals PHP, as you can see, the compiler is complaining because it says val cannot be reassigned, which means a val variable is immutable. Another thing you might notice is that when we define our variables, either it's a val or a var, we didn't specify the type of this variable. Kotlin is very flexible in terms of the syntax for giving a type to a variable. If we don't give any type, the Kotlin language will infer the type based on the context, based on the value that we give to that variable. But if we wanted to, we can specify the type by adding a semicolon after the variable name. So just like this. And then we say the variable name, variable type, which is string. So that's how we specify the type of our variable. And the same thing applies here. We can say string. But we can just omit that, and the Kotlin language will infer the type for us. And just to remember, Kotlin is also a statically typed language. Even though we didn't specify the type, once it is assigned to a value, it is fixed to that type. So once we do this, once we say name equals Kotlin, the name variable, it's a string type. We cannot give the like an integer or double to our name variable. Same thing goes for our var variable. We cannot give the integer or double to our language. Next, let's talk about a very big improvement in Kotlin language over Java regarding variables, which is the null safety feature. So in Kotlin, if we want our variable to be able to store the value of null, we need to explicitly tell the Kotlin compiler that we want this variable to be able to store null value. Otherwise, it can't. So let me explain what I mean. Right here, I have this language variable, which stores the value of Java. If I try to give a null value to our language variable, let's see what will happen. So I say language equals null. As you can see, we got a compiler error. It says null cannot be a value of a non-null type string. So in order to make our language nullable, we need to explicitly define it as a nullable string. So the way to do that is to, when we define our language variable, right after the language name, the variable name, we say colon, and then the type of this variable, which is string, and then we add a question mark. So this way, with the question mark added, language can now store the null value. Let's take a look. So language equals null. This time, the compiler doesn't complain, which means we can give null value to the language variable. Next, let's talk about string templates. So basically what string templates is that Kotlin allows us to use variables and code snippets inside of string literals. So for example, if we wanted to print out hello Kotlin, in our case, what we can do is to use string templates. So we say $, and then followed by the variable name. And this way, we can print out hello Kotlin. And let's take a look. So right here we have hello Kotlin, right? And if we want to execute some sort of operations, we can use a $, followed by a pair of curly braces. And inside of curly braces, we can have some complex expressions. And to demonstrate that, let's try to do like 1 + 2. Let's see if that works. And it should be print out hello 3, right? Yeah, it says hello 3. So this is string templates, very flexible when we want to combine it with string literals. Next, let's talk about arrays. So unlike in Java, arrays is a class in Kotlin. So in order to create an array, we need to call the arrayOf method from the array class. So let me show you how to do that. If we wanted to define an array, let's call the array ARR, and then we call the arrayOf method, and then inside of the parentheses, we give the value of the array. For example, we wanted to store some integers. We can say 1, 2, 3. So this way, we create an array with the element of 1, 2, 3. And in terms of accessing specific elements of the array, it's the exact same as in Java, where we use square brackets. So let's print out the array elements. Let's print out ARR square brackets index 0. Let's take a look. Let's comment out the first print line, and let's take a look. We should get 1 printed out. Right, we get 1 printed out. Since array is a class, whenever we use the square brackets to access a specific index, we essentially are calling the get and set method from the array class. And Kotlin also has specialized classes to represent arrays of primitive data types. It includes int array, byte array, and short array, and so on. So for example, if we want to define an int array, what we can do is we can say int array colon, this is int array, and is equal to int array of, inside of the parentheses, let's give the value of the array. So you can say 2, 4, 6, 8, 10, and so on. This type of arrays have no inheritance relationships with regular arrays, but they do have the same method and properties, so you can use across the board with all type of arrays. So next, let's talk about some control structures in Kotlin. First, we're going to talk about how to compare conditional branches in Kotlin. The number one method is obviously to use the if-else, just like any other languages. We can use if-else just like we use them in Java to make a comparison, and then if it's true and we do one thing, and if it's not true, we do another thing using the else branch. Right, so let me show you how to do it. So for example, let's define a variable called age, and I want to read this from the console. So we call the readLine method, and we need to convert the readLine into an integer. So we do integer dot value of, and so before we do that, let's print out a message so that we know we need to enter our age. So please tell us your age. So, and then let's do the if statement. So if age is greater than 21, and we want to print out you are allowed to drink. Else, let's print out you're not allowed to drink. So if age is greater than or equal to 21. So now let's run this. Let's first comment out the first previous print lane, and let's run this program and enter our age. Say my age is 57, and then you're allowed to drink. And then let's run this again. And this time my age is 14, and you're not allowed to drink. So that's how if-else works, just like in any other languages. But the differences in Kotlin is that if-else is actually an expression, which means it can take a return value, and we can assign that return value to a variable and use it later on in our program. So let me show you how to do that. So before the if statement, let's define a variable, val, and let's call it results. And let's assign this to our if statement. And then we print out on inline with the if statement, and we remove the print lane, and the parentheses follow it. So we remove the other print lane. So now what this does is that if our age is greater or equal to 21, the result is going to be you are allowed to drink. Otherwise, results is going to be you are not allowed to drink. So after that, we can just print out our results. So print out results. Let's run this. We should get the same result as before. So my age is 39. You're allowed to drink. This time, if my age is 11, you're not allowed to drink. So that's what I mean by assigning if-else statement into a variable. So that's very convenient if we want to store the results and use it later on in our program. So that's if-else, and now let's talk about how to evaluate multiple branches, more than 2 conditions. So for that, in Kotlin, we use the when expression. So let me show you how to do that. First, let's comment out the part of the if-else. And for example, I want to know what I want to eat based on the day of the week. So let's see. So first I want to print out a message asking what day is today. All right. And then let's define a variable and let's call it day. And let's read it from the console. And then, so let's see. Now let's evaluate different situations. So we use the when operation, and follow that is our argument. We want to see what day is today. So the different scenarios are if today is Monday and we want to eat chicken, and then if today is Friday, what I want to eat is salmon, and if today is Sunday, I want to eat steak. And for every other day, every other situation, I just want to eat bacon. Okay? So that's how we use when statement. That's the syntax of when. We use this symbol, a dash with a greater than sign, to connect the condition and the results. Okay? And notice that there is no break statement after every condition. And after that, let's print out the results. Actually, let's print out each result. So let's print out salmon as well. Let's print out stick, and then lastly, let's print out bacon. All right, let's run this and see if we can get what we want. So, what day is today? Today is Monday. Oh, I'm sorry. It should be lowercase o. So today is Monday. Oh, oops. That should be N. Let's try that again. At least we got the bacon right. Monday. Finally, there we go. We got chicken. And let's try that again. Today is Sunday. And we got stick. So that's right. And notice that when, just the same with if and else, it's also an expression, which means we can store the return value in a variable and then use that later on in our program. So we can define a variable, let's call it food, and let's set it to the when expression, and then we remove every print lane from the results. Now, lastly, let's print this out after the when expression. So print out food, and let's run this. So what day is today? Today is Monday. We got chicken, and today is Tuesday. We got bacon because it's not listed in the first three branches. So that's how we use when, which is very, very similar to the switch statement in Java. And one more thing I want to mention is the since there's no break statement, once we matched with one condition, the when is stopped. We stop doing compare other branches. But if we want to match multiple scenarios with one results, what we can do is we can use the comma to separate different scenarios. So for example, I want to eat chicken on every Monday and Wednesday. So that's how we add Wednesday to that chicken branch. And let's add Tuesday with the salmon branch, and let's run this. And today is Tuesday. We got salmon. So that's how we evaluate different multiple branches to the same results. So another way to use when is to use when without arguments. So let me show you. Let me rewrite this whole example with the when, but without arguments. So let's first comment this out. And down here, let's define the food again equals. And this time I call when, and without the parentheses and arguments, followed by the curly braces, and inside of curly braces, I compare day. So if day is equal to Monday, then what I wanted to do is to give the food the value of chicken. And if day is equals to Friday, assign salmon to food. And if day equals Sunday, let's give the value of steak to food. For everything else, just assign bacon to food. So it should be the same result as before. I just wanted to show you that we can use when without arguments. Today is Monday, we got chicken. And if today is Wednesday, we got bacon. So that's the two different ways to use when expression in Kotlin to do multiple conditions comparison. So let's move on to the next control structure, which is looping. In Kotlin, we have three ways to loop through any collections, which are for loops, while loops, and do while loops. While loops and do while loops are exactly the same in terms of syntax and usages as in Java, so I won't waste time talk about those. Instead, let's just focusing on for loops and see how it is different from Java. Now, let me show you some examples. First, let's comment out the when expression and also this part. And I'm going to use this int array, and we're going to define some other collections as well. First, let's define a list. List equal to list of string, and I want to have Kotlin and Java, Python, and C++. And let's define a map. So map of, let's give it a key. So key is 1 to Kotlin, and 2 to Java, 3 to Python, and 4 to C++. So now let's loop them and see how the syntaxes are different. So we say for, and first let's loop through the int array right up here that we defined earlier. So first is the variable. I'm just going to use a. So the keyword to loop through any collection is to use in. And after in, we say our collection name. In this case is IA. So for the purpose of this tutorial, I'm just going to print out the content of our collection. So let's print out A. And we should get 2, 4, 6, 8, and 10. So let's take a look. So there we go. We got the exact result that we wanted. And we can use the same syntax to loop through a list. So let's change this to our list. And let's print lane every language in our list. And let's run this. We got all 4 languages printed out. We can also loop through a map using a key value pair. So in our for loop, I would say I want to use key value, and inside of map, right? And then to print, I want to print key. Here I use the string template and map to value. Value is also a string template. And let's run this program. We should get every key value pair printed out. So basically, to loop through any collections, use the in operator. And if you want to work with indexes directly instead of a collection, we can use ranges. So let me show you another example. First, let's comment this out. And let's do another for loop. I is our variable name. And we also use the in operator. And we want to loop through index 1 through 9. So I say 1 dot dot 9. So the dot dot operator represent a range. And inside of the loop, let's just print out I. And let's run this. We should get 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you don't want to use dot dot, you can also use the keyword until. Okay, and let's run this and see the differences. This time we got 1, 2, 3, 4, 5, 6, 7, 8, which means the until keyword exclude the upper bound of the range. And we can also do steps. So we can do step 2. Let's run this. Right, we should get 1, 3, 5, and 7. So we increment the index by 2 every time we loop. We can also do countdowns. So to do countdowns, we count from 9 down to 1. So we do down to 1. And let's print out. We got 9, 8, 7, 6, 5, 4, 3, 2, 1. So down to is the operator you want to use if you want to count down, and it is inclusive both the upper bound and the lower bound. Next, let's talk about something that is introduced in Kotlin but not present in Java, which is the extension function. Extension function is basically a function that is defined outside of a class but can be called as a member function for that class. So let me show you that through an example. Say I want to define a function called getEmotion, which is to get emotion from the input string. If the input string end in a exclamation mark, the emotion should be exciting. If the string ends in question mark, the emotion is curious. If the input string ends in a period, the emotion should be calm. And for everything else, the emotion is unidentified. So let me show you how to make that getEmotion function as a extension function for the string class. Let's first comment out our for loops. And down at the bottom, just like we define any other functions, we use the fun keyword. And then we need to specify the receiver class. In this case, is the string class. And then we use a dot followed by our function name, which is getEmotion. And then parentheses. Now the colon, and specify the return type of this function. In our case, it is string. And then curly braces. So here is our function body. We want to return a emotion based on the last character of our input string. So we need to use the when expression that we talked about earlier. And we can directly return this when expression from our function. So we do return and then when curly braces. So inside of the string class, we have a method called last, which is to get the last character of a string. So if the last character of a string equal to an exclamation mark, we want to return the emotion of exciting. And if the last character is a question mark, let's return curious. And if the last character is a period, let's return calm. And for every else situation, let's return unidentified. Okay? So, now let's define a string. Let's see, it's a let's say, how are you? Question mark. Let's print out s dot get emotion, and let's run this. See if we can get curious, because we ended in question mark. And if I have a exclamation mark, let's run this. We got exciting. And if we don't have any marks, we just end on how are you, we got unidentified. So that is how we define a get emotion and extend that to the string class. And in fact, most of the Kotlin library functions are extension functions on top of Java classes. So there's no concept of Kotlin SDK. There's only Java JDK plus Kotlin extension functions. So understanding how extension function works can really help you understand how exactly our Kotlin code works under the hood. So that's the basic structure of Kotlin code. Next, let's talk about object-oriented programming in Kotlin. First, let's create a new package in our source folder. So let's right-click on source and select new and then package. Let's call it OOP. And then inside of our package, let's create a new Kotlin file. I'm going to use the example from my Java tutorial, which is the person, employee, and student example. So let's call our class person. And in the drop-down menu, let's select class, and we click OK. So Kotlin created the package and the class for us. First of all, let's define some properties. We can do this the old-fashioned way, which is like what we did in Java. We define first name and last name and then an age, all right? So we can say val first name, and then this is a string. And then val last name, also string. And then val age, this is int. So since we're defining them as val, they're immutable, so we need to give them a initial value. So I'll say first name is John, and then last name is Smith, and then age, we give it initial value of 19. All right, and then let's go back to our main function. So let's comment out our function right here, string function. And then first thing first, we need to import our person class. So let's import on top op dot person. And then let's collapse them. And right. So down at the bottom, let's define a new person. So val p1 equals. Remember, there is no new operator in Kotlin, so we just call the person as a function. All right, so person parentheses. So this will give us a person object, which is assigned to the variable p1. And then let's print out so my name is $. Let's use string template p1 dot first name plus no, not plus, since we're using a string template. So just space and then $, and then p1 dot last name, and I am $p1 dot age years old. All right, let's run this and see if it can get the properties from our person class. So my name is John Smith and I'm 19 years old. So we can just call properties directly without any getters and setters. But under the hood, Kotlin actually creates a default getters for us. So even though it looks like we're directly calling the properties, but we are actually calling the getters that the Kotlin compiler set for us. Now let's go back to our person class. Note that since we are defining our properties as a val, we cannot change them once they are initialized. So in order to be able to change the value of our property, let's define them as a var. So let's change all the vals to var, and then let's go back to our main function, and let's try to modify p1. So p1 dot age, let's give it to 10, and let's print this out. Let's try again. So yeah, so we successfully changed the age property of our p1 object. Now that's the old-fashioned way. That's the Java way of defining properties. In Kotlin, we can actually do all of this in one line of code. So that's to use the primary constructor right after we define our class name. So let me show you how to do that. So in order to use the primary constructor, what we can do is we can say constructor after our class name, constructor, and then parentheses, and then let's move everything down here into our parentheses. And we follow every property. We have a comma, all right? And then we can move them into one line. And if we run this program now, we will get the same results. So basically, this is more look like a Kotlin code. What happens under the hood are still the same, but this is more simpler and concise and looks like a Kotlin code instead of plain old Java. And one more thing to notice that if there is no method declarations, we can actually omit the constructor keyword and just use parentheses. to represent a primary constructor. So the code still works the same. So with the primary constructor, it also comes with a set of getters and setters for all the properties inside of the constructor. But we can also define custom getters and setters if you want to use them. So for example, if I have a property called full name, and let's define this. So val full name, and then this is a string, and we want to define a getter for our full name. So we say get, and it equals. I want to return $, first name space $, last name. So this is actually a custom getter. Since full name should be constructed using first name and last name, we don't want to specify any custom setters. So we define this as val, which means it's immutable and we cannot change this. And now let's head back to our main function. Let's define a new person object. So we say val, and then p2 equals person. And let's try to initialize our person with different values than the default constructor values. So we can use named parameter here. So we say first name equals Peter, and then last name is Jackson, and then age, which is 29. And this way, we can override the default values in our constructor. And let's try to print out P2's full name. So let's run this. And we got Peter Jackson. So that's how we define our custom getters for our property. And one more thing to notice is that if you want to have custom getters or setters for your property, you cannot put the property inside of your primary constructor. Otherwise, you will be stuck with the default getters and setters. So for the most part, the default primary constructor is good enough for most of the use cases. But if you really wanted to, you can create secondary constructors in Kotlin. So for example, we can have a variable that changes our age with initialization. So what I can do is I use a secondary constructor I call constructor. And then this takes a parameter, I call this here, and it's of type of int. And then here is our constructor body. So for every secondary constructor, we need to delegate to our first primary constructor by using the this keyword. So this means, we need to delegate the initialization to our primary constructor. And then inside of this, we say age and increment age by the number of years. And let's go back to our main function, and let's create a new object. Let's call it P3. And this time, let's use the secondary constructor to initialize our person object. So it will take a year parameter, and I want to increment age by 3. And let's print out the exact same sentence from my P1 example. And let's change P1 to P3. And also the age. So first name and last name should still be John and Smith. And the age, instead of 19, the default value, it should be incremented by this parameter, which is 19 plus 3 should be 22. And let's run this and see if we got 22. So my name is John Smith and I'm 22 years old. So that's how you use secondary constructors to change the initial value of your property. But for the most part, the primary constructors is good enough. We usually don't need to create additional constructors other than the default primary constructor. The downside of a primary constructor is that we cannot put any code inside of it. If we wanted to do some calculations and operations during the initialization phase, we can put the code inside of a init block. And let me show you an example. So for example, I want to be able to have an ID field for each person, which is a combination of the person's full name concatenated with the person's age. So let's first define an age field, the ID field. Let's do that after the secondary constructor. So I say val and then ID, which is a string. And then without initializing this ID field, let's put that inside of a init block. So I say init and then curly braces. And inside of init, I want to combine the full name plus age. And this is the ID field for each person. And let's go back to our main function and let's try to print out, let's use P2 first. So println, so P2 ID is $, so P2.ID. And let's take a look. So the P2's ID is Peter Jackson 29. So Peter Jackson and 29. So that's how we combine full name with age to create the ID field. And now let's try to print out the P3. Let's print out the P3's ID, which should be first name plus last name plus the year, the age. And let's run this. Now we got P3's ID is John Smith 19. But notice that in the last print lane, John Smith's age is actually 22. So the reason why the ID uses the age of 19 instead of 22 is because the init block is part of the primary constructor, which is always run before any secondary constructors. So before we increment age by the parameter of year, we actually already initialize the ID field with the old age, which is 19. So that's why the ID uses age 19 instead of 22. And we can have multiple init blocks inside of our code, and all of them are all part of the primary constructor, and all of them will always run before any of the secondary constructors. Next, let's talk about inheritance. We wanted to create a class called employee, which extend the superclass, which is person. So let's do that inside of our person.kt file. And below the person class, let's say class and employee, which should take a parameter called company, and which is the type of string. So this should inherit from the person class. Okay? And notice that there's an error. That's because the type is final, cannot be inherited. So in Kotlin, the class as well as member variables and the functions are by default final, which means they cannot be inherited. In order to make them inheritable, we need to mark them as open. So in front of the class keyword, we use open, and if we wanted to override any of the properties, for example, I want to override ID, let's mark this open as well. So in our employee class, let's override the ID field. In order to override, we need to use the override keyword. So override val ID equals still full name. We can directly use full name from our superclass, and plus company, and then plus age. So that's how we override the properties from our person class. Now let's go back to our main function and let's print out. Let's first create a employee object, and employee should take a company name. Let's give it XYZ, and let's print out E1's ID is $E1.id. And let's comment out the previous printlings. And let's run this. Now we got E1's ID is John Smith XYZ19. So that's how we do inheritance in Kotlin. So speaking of inheritance, let's talk about abstract classes and interfaces. So I can change my person class into an abstract class just by replacing the open keyword with abstract keyword. And then we can change the open in front of the ID field into abstract. So marking a field as abstract automatically make them open, so we don't need to specify them as open. But we need to comment out the initialization of ID because since they're abstract, they cannot be initialized. And inside of the employee class, we can just override the ID field. Okay, and let's create another class and call it student. And this time we take a parameter, say school, and it's also a string, and then it extends the person class, and we wanted to override the val ID, full name plus school plus age. And let's try to run that. And let's go back to our main function. Let's comment out every initialization of the person object. Since person is now an abstract class, we cannot initialize them. And let's print out so E1's ID, and then let's create another student object. The school name, let's give it A, B, C, D, and then print out S1's ID is $S1.id. And let's run this. And we get E1's ID and S1's ID. So that's how we use abstract class. And we can also create interfaces in Kotlin. So let's go to our OOP package and right click on it and select new Kotlin class. And let's call it person actions, and it is a interface, and click OK. So for person actions, let's define a function. So every person should like wear clothes. So the function would be wear clothes. Okay, and that's a function inside of an interface. Now let's go back to our person.kt file. Inside of the employee class, let's make it implement our person actions interface. So we do multiple inheritance by separate the classes using a comma, and we do person actions, and we need to implement which is to use override keyword fun where clothes. Okay, and let's try to print out employee wears suit and tie. And then inside of student, let's make it inherit from implement person actions, and then let it override the wear clothes method as well. So this time, let's print out student wears uniform, and go back to our main function. Let's call e1 dot wear clothes and then s1 dot wear clothes, and let's print. We got employee wears suit and tie, student wears uniforms. So that's the basics of interfaces and how do we use them and create them and call them in Kotlin. So that's pretty much all the things that I want to talk about in this Kotlin crash course. And I believe that is enough to get you started with Kotlin. And you can use this knowledge to explore more advanced features in Kotlin. So thanks for watching and hope you guys learned something. I will see you in the next one.